So I asked you to do an experiment in the end of the circle 2 where you picked a radius that was twice another radius. So let's look at area here. Pi r squared. So pi by 2 squared, which is 4 pi. That's the first area. And the second area is pi by 4 squared, which is 16 pi. And if we compare these two, 4 pi to 16 pi, when we divide by pi, is 4 to 16, which again is 1 to 4. So lock this bit of knowledge away. Well, what would happen if we tripled it? Now we've gone from 2 to 4. If we triple 2, we're going to get to 6. So let's see what happens if we triple our radius. Pi r squared for the area, it's going to become pi by 6 squared, which is 36 pi. So you can see the relationship of what's happening here. The square part is what's really making these things get bigger. So it's a squared relationship here. So we're dealing with a 4 pi against a 9 pi. Sorry, against a 36 pi. So we're looking at 4 to 36, which is 1 to 9. And you can see here, 4 is 2 squared for the doubling, and 9 is 3 squared for the tripling. Now, what would 4 squared give us a relationship of? 4 squared is 16, so the answer should be 1 to 16. And we're just going to investigate, is it? And then you guys are going to put these notes into your copy, and you're going to have this knowledge of a circle. That's going to help you going forward. And then in the end of this video, we're going to look at, well, what if this circle was the top of a Coca-Cola can? So let's just look at one more. Area when the radius has been quadrupled. So from 2 to 4 to 6, quadrupling 2, we get to 8. So we have pi by 8 squared. So this is when my radius is 8, which is 64 pi. So if I compare the two, if I compare my 4 pi when my radius is 2 to my 64 pi, I get 4 to 64, which was 1 to 16, which you told me was going to be the answer a minute ago. So you can see the relationship between area here and the length of the radius of a circle. Okay, now let's introduce going from 2D to 3D, which we have loads of questions in the playlist on 3D shapes. So here's my can of Coke, or can of Monster. You probably guys don't even know what Coca-Cola is anymore. So Coca-Cola is a drink, it's in a red can. Okay, now let's say the radius of this can is 7. So what we have when we're dealing with what this shape is now a cylinder. So it's gone from 2D, which is the circle, and we've put loads of circles on top of each other. If you imagine, keep on going down like this, loads of circles on top of each other, and eventually, all those circles on top of each other form this cylinder. Now, this is the bit that I'm concerned with just at the end of this video, the circle part at the top. Now, what's the distance around this circle? So if we were asked to find the area of the metal involved in making this can, we have this circle here, we have this circle here. They have to be the same, even though my diagram is a bit wockety. They're both the same. So we have pi r squared by 2, which is obviously 2 pi times 7 squared, 2 pi r squared. So that's going to give me 49 times 2, 98 pi. And that would be in cm, as we're dealing with a can of Coke here. And if I say pi is equal to 3.14, we could get a value for this. And I get 307.72 centimeters squared. Now, how do I get the area of this curvy bit of the can? Now, if we imagine, if I just draw a little what's called a net of this shape, and you haven't gone on to nets yet, but you will be. We're going to have a circle at the top and a circle at the bottom, and what we actually have is a rectangle. Now, if the height of this can is 20 centimeters. It's one of the old supersized cans of Coke. This bit is 20. Okay, now what we need is, we need the bit along the top. So what is this bit here? Now the circle fits perfectly onto it, so it has to be the same length as the distance around the outside of the circle. So the area of this rectangle, I'm just going to draw it again. There's going to be a 20 here, and along the top here, the circumference of a circle is 2 pi r. Remember, 2 pi r is equal to c. So 20 by 2 by pi by 7 is going to give me it's going to give me 47's to 80 pi, which is equal to 879.2 cm squared. So the total area, we just add these two guys together. So that's why it's important to have the knowledge of the circle before we move on to 3D shapes, which is just what I wanted to introduce at the end of this third circle video. So hopefully at this point you've mastered 2 pi r, this distance around the outside, pi r squared being the area, which we'll represent by the letter A, and just the letter C for circumference. The letter A for area. You guys are now masters of the circle, and when you move on to cylinder, you'll go, oh yeah, kind of remember why this top bit here, this rectangle, has one side that's actually got a length of 2 pi r. Keep that in the back of your brain for when we get on to 3D shapes.